Hello there, I'm Thomas Hatsios, the German-American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport runway 1449 West localizer landing. So right now I'm in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 in the Microsoft Flight Simulator X. I'm going to start assigning you the cockpit, the instruments, the displays, and the functions of the Boeing 787-900 jet aircraft. I'm gonna start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the magnetic heading and track, the magnetic north pole and true north pole magnetic variation depending on where we are in the world. We have also the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, and the altitude selected from the autopilot and flight director system panel. We have also the vertical rate of climb and descent of the aircraft in tens, hundreds, and thousands feet per minute, or the steepness of the trigonometric angles in degrees can climb and descent. We have also the altitude indicator with the artificial horizon, the pitch ladder in degrees, the blank angle in degrees, the Lszh localizer for the approach to the runway. We use the instrument landing system. We have the horizontal localizer and vertical glide slope, and also the Lszh localizer crossbars. We have the Lszh localizer frequency name displayed the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, the flight mode enunciated with the autopilot and the auto throttle later and vertical navigation modes. So I'm gonna show you also the navigation display that displays the inertial reference, the GPS position of the aircraft. You can see also the terrain and weather reflections from the terrain, from the weather radar. You can see the red, green, and yellow color of the terrain elevation, the distance. You can see the horizontal and the vertical profile of the radar scan. Also, we have the terrain map with the airports where they are located, the navigation aids, the waypoint fixes, the ADFs, the NDPs, and the board stations. So you can see also the magnetic north pole and the true north pole and magnetic variation depending of where we are in the world. We have also the other aircraft, the air traffic that fly around our own aircraft, the distance where they are located, the altitude difference from our own aircraft, whether they climb, the descent. Also, the system calculates the airspeed of the other aircraft, so it generates the warnings. You can see the diamond shape of the other aircraft in the navigation display, and generates the TICA system, the traffic collision advisory system. We use the ADSP and ADC transmitter receiver that transmits our frequency to other aircraft in the air traffic control. Also receives from other aircraft in the air traffic control, and thus this way generates this display of the other aircraft. You can see also the wind speed direction, the ground speed, the next waypoint we're going to be overflying. Also we have the flight management computer. I'm gonna show you. We input all the data. I have done this already, created a flight plan. So I input the data of the aircraft for this flight that include the takeoff gross weight, that is the empty weight plus the passenger plus the cargo plus the fuel on board, the trip fuel, the reserve fuel, and the taxi fuel. Where is that fuel stored in the left and right wing and the center tank. We have the calculations of the center of gravity of the aircraft and the mean aerodynamic chord position, of the forward wings, the Mach that is about 33% right now of the mean aerodynamic chord is the position where the maximum aerodynamic lift occurs in the wings, in the top surfaces in the wings, also where the stall begins for a given angle of attack when we fly. So is also the position where the center of gravity should be placed for an airliner aircraft. Also this axis transverses the longitudinal axis of the aircraft from the nose to the tail, all the way back to the tail. So the horizontal tail of the aircraft is being trimmed automatically from takeoff, climb, cruise, descent, and approach, and this is calculated by the flight management computer all the time. Also, we can trim the horizontal tail of the aircraft. The horizontal tail trim stabilizer using the trim switch. I'm gonna show you in the control, in the flight controls control wheel. So we can trim the horizontal tail of the aircraft all the time to balance the aircraft in flight from takeoff, climb, cruise, descent, approach, and landing. So we have also the we use all this data. We input also the flaps for takeoff. We're gonna use like 15 degrees for this flight, and we select the runway we're gonna use for departure. The flight management computer has the data stored of the runway length, the runway slope, the wind direction and speed, also the temperature of the air, the pressure and the density of the air, the wind direction and speed, and we have the calculations about the takeoff speed of the aircraft, the V1, V-rotate and V2. So we're gonna have this takeoff speed displayed in the primary flight display after we select them in the flight management computer. I have done this already, so we're gonna make a complete route or flight plan or flight path for this aircraft from takeoff, climb, cruise, descent, approach and landing. We're gonna select the departure, airport, runway, the seats, the southern instruments, departure, intermediate that include horizontal and vertical navigation fixes. You can see in the navigation display as waypoints for the initial climb, also altitude and airspeed constraints, and we have then after that on the climb to the cruise level we have intermediate waypoints and fixes, and the destination airport and runway. We have the stars as we descend for approach and landing. We have the stars, the standard terminal arrival waypoints and fixes that include horizontal and vertical navigation waypoints and fixes for the approach and landing. Also, the destination airport runway, we have the magnetic heading of the runway we select for an ILS localizer landing. We're gonna have the descent of the aircraft using the horizontal and vertical glide slope. You can see the horizontal localizer and the vertical glide slope display in the primary flight display. If we select the ILS localizer, the instrument landing system and the magnetic heading orientation for this for this flight, so you're gonna see that display in the flight management computer. We can select that automatically when we select the runway for landing, or manually using the radio management panel to tuning of the navigation aids. So you're gonna see also we have so this I think is enough for the flight management computer. We have also the LNAV, the VNAV, the lateral navigation, the vertical navigation of the aircraft, which are interconnected here in the autopilot flight director system panel. So you can see here we have, so you can see here what we have. So you can see the data here we have stored in the flight management computer. We created a flight plan, and this is displayed here. You can see also the flight director, the airspeed selected, the altitude select, the radio altitude, the flight plan we created here. So we have to climb, cruise through here. You can see far away some waypoints like this. Also here we have the flight plan created. So you can see the flight plan here, the waypoints we have to follow. You can see also if we're closing enough, you will see the runway displayed here that we are located. You can see the orientation of the aircraft on the GPS map. Also, when we have a mountain in front of us, and this is going to be the climb we have to use. So you can see the runway here displayed like this, the two runways. So you have the orientation of the two runways here. In this display, the navigation display, we have also the flight plan like this. How far away we look, we have some maybe other airport and runways, and also the terrain. You can see some terrain here that is interesting. You have some mountains in this distance when you look in front of you, so you have to avoid these mountains when you fly. So we're gonna climb through that, also descend. Then as you can see here, these are the vertical profile, the VNAV function. This is the LNAV, the lateral. So you can select this like this. So we have maybe a closer look. You will see the waypoints we have to fly through. This is gonna be the approach actually after takeoff. You can see also maybe the center view of the flight plan, just like in the other airliners. So we're gonna climb from here and come this way and then return back, as you can see in the map. Display also here, so climb here, cruise through. So we're gonna have the rest of the systems now. I will show you also. You can see the flight controls here. I will show you in a couple of seconds. The thrust levers, the flaps and the slats, the speed brakes. We have the horizontal trim, stabilizer, the cutout switch here. You open this guarded switch, the fuel flow to the left and the right engine, the overhead panel here. So I'll show you how to make all the settings. So after that, you can see here we have the autopilot flight director system panel. So we have autopilot flight director system panel. You can see the airspeed guidance of the aircraft, the autopilot engage and disengage switch, the flight director, the auto throttle left and right. You can select an airspeed here. You can select the heading of the aircraft, the bank angle as it flies, the vertical rate of climb, descent of the aircraft, 100,000 feet per minute, the altitude, the Lszh localizer, the Warlock, and the approach for the auto land. So these are the two auto throttles, engage and disengage switch. Also these the thrust levers has the auto throttle disengage switch. Here you press this switch and you disengage the auto throttle. You have also the takeoff ground switch and the thrust reverse, so I'll show you that. Also so we have after I'm showing you the navigation display, the flight plan we have created. So I use this flight management computer here to create the flight plan. As you can see, so here is the flight plan I created using this page, the route over here, the departure and arrival destination, the runway we're gonna use, departure arrivals here, select. We have the waypoints from initial climb and then cruise level, top of climb, top of descent, then approach and landing here, the runway. We have the runway 14, then we have a go around if we need again. So this is the waypoints, navigation fixes, holds, fix, progress, vnav, alternate. So we have the root, the initial reference. We use we have the index, the performance. So we use this gross weight here for the calculation. You can see fuel on board, zero fuel weight, reserves, cruising altitude, cost index, and center of gravity for cruise. Also the takeoff, we set the flaps, center of gravity and trim, the horizontal trim of the horizontal tail 4.25 degrees, and the takeoff speeds. So this is all the calculations we need for the Boeing 787-900 models. I'm gonna show you now inside the cockpit again. So now I'm gonna show you and talk to you about the autopilot and flight director system panel. We have the autopilot engages and disengages, switch the auto for left and auto for right, engage and disengage, switch the airspeed, select no because select on airspeed, no to nautical miles or max speed, and select the modes like LNAV, VNAV, flight level change, climb continuous, and auto throttle with the speed mode. So when we select an speed guidance for the aircraft, this commands the thrust levers and the engines. N1, we have the N1, which is the low speed starters, low pressure compressor and turbine of the turbofan, which is engine, the exhaust gas temperature per engine. So this is controlled, the N2, which is the high speed starters, the high pressure compressor and turbine of the turbofan, which is engine. You can see all this displayed here. Like the N1, which is low speed starters, low pressure compressor and turbine of the turbofan, which is engine, the left and the right engine, the exhaust gas temperature. The N2, which is the high speed starter, the high pressure compressor and turbine of the turbofan, which is engine, the fuel flow per hour, the pressure, the temperature, oil quantity, and the vibration of the N2 states of the engine. So when you select the airspeed here, guidance of the aircraft, you give a command here to the engines, control, electronic engine control. You have also here the electronic engine control in the overhead panel. So these commands, the engines. We have the GNX9 engines, I think so. So they are turbofan, turbojet engines, jet engines kind. So we have one in the left one in the right one. First cylindrical thrust doesn't see its engine contains a gearbox. The gearbox contains the FADEX. The FADEX are the full authorities electronic control computers. One installed per engine gearbox. Controls, monitors, and displays the functions of the engine using the upper and the lower ACAS and its indication and controller system display, like the N1, which is the low speed starter and low pressure compressor and turbine of the turbofan, which is engine, the exhaust gas temperature per engine. The N2, which is the high speed starter and the high pressure compressor and turbine of the turbofan, which is engine, the fuel flow per inch per hour, 1,000 kilograms or thousands of pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 states of the engine. Also, you will see the thrust levers over here moving automatically when you have set the auto throttle. So you will see the N1 here change. You can see the changes of the N1 as you have a commanded thrust. Position takes like 2 seconds from the actual to the commanded when you request a higher or lower setting. To anticipate that in flight, it takes some time for the engines to react. Also, the FADEX control engine sergeants, shutdown, engine failures, fuel flow as we climb and we descend the aircraft to higher or lower altitudes. We have different air pressure and density. Temperature of the air is freezing in the higher altitudes, so the aircraft flies faster. So we have higher intake of air into the engine. So we need a different fuel air mixture adjustment every second. So this is done automatically using the FADEX. Also, the FADEX control other sensors like fuel heat changer and also the pressure inside the engine and the outflow pressure from the left and right engine, the fifth and the ninth stage. of the dermated and high pressure of the turbofan. So we have also so this is the main functions of the Farex engine: starting, shutdown, fuel flow, fuel control. We have the left and right fuel control to the left and the right engine. Over here the fuel control, you can see left and right engine, also thrust reverses, and here you can see the auto start and electronic engine control. So we're gonna use the auto start later to start the engines. So we have also the thrust reverses. Here you can see, so this indicates the reverse. So the blocker doors here open, and um, you can see the blocker doors open like this, and then close, disarm, and open again. So you pull up this handle to have the thrust reverse. So I'm explaining you about the autopilot director system panel. We have a few more minutes. So the airspeed select knob, you select the airspeed. For the airspeed guidance, this will command the thrust rating, as I told you, the N1 or the engine power rating from the Farex automatically. Also, as you climb and descend, you have two main modes. As you climb or descend, we have the fixed thrust mode, like in the climb or takeoff or climb. We have a maximum continuous thrust. When we descend, we have idle thrust. In either case, the airspeed of the aircraft is being adjusted by varying how fast the aircraft will climb or descend to the target altitude by commanding the horizontal tail trim stabilizer position automatically during the whole flight from takeoff, climb, cruise, descent, and approach, and landing. Also using the elevator of the horizontal tail of the aircraft. So also you also that in the flight control section. Also, as the aircraft is flying horizontally in a horizontal flight path or in approach and landing, we have the variable thrust mode in which the airspeed is being adjusted to varying the thrust produced by the engine. Also, we have the LNAV and the VNAV, the lateral and the vertical navigation of the aircraft. From the flight management computer, we have the bank angle limit, the heading select node, the heading hold switch, the vertical rate of climb and descent of the aircraft tends 100,000 feet per minute, and the trigonometric angle to decrease the FPA mode. The steepness of the trigonometric angle is strictly up, climb or descent. We have the altitude select node, the altitude hold switch, the VOR localizer for the Lszh localizer approach, and the approach switch for the auto land function of the Boeing 787-900 aircraft. So we have later, you can see we have the horizontal trim stabilizer here. As I told you, you can trim the horizontal tail of the aircraft using this switch here, very important. This is the horizontal tail of the aircraft, and you can trim, because I'm gonna start showing you now the flight controls. You can trim up and you can trim down like this the tail of the aircraft during the whole flight. So you can see the elevator now moving up and down the left and the right. So you can trim the whole surface of the tail as you fly like this using this trim switch. Also you will see we have the rudder trim and the position adjusted by the horizontal trim stabilizer in degrees. You can see it here, 4 degrees or 4.25 up and down the stabilizer. We have also the rudder trim, the flaps here position, the landing gear extend and retract, the normal and alternate here, landing gear, and the lock override. We have also the auto brake here. You can select the auto brake function. So some other displays not related to that. So the flaps, the landing gear, the flaps here, you said how many degrees of flaps you need. So you can retract like this. You'll see different flap requested here, like 18, or 0. If you fully retract, you can set back, fully extend the speed brakes here. So you can retract the speed brakes like this. You can see the speed brakes extend. Like this. You can see. So this is what extends the speed brakes. It makes the aircraft lose some airspeed. So I told you we have the fuel controls, left and right engine, auto throttle disconnect. Also we have, I told you, the horizontal trim here of the horizontal tail stabilizer. We have the electronic flight pack here for flight. Contains a lot of information also later. Performance terminal charge. So we have the horizontal trim stabilizer. We have also the parking brakes here, up and down. So you arm the parking brakes like this. We have the alternate speed string here. So we have the L and the R, the stabilizer from normal to cut out. If you have a failure here of the horizontal trim stabilizer because of the hydraulic fluid on the CMDR system, we're gonna lose the auto trim from the autopilot and flight director system panel, and we have to use only to cut out this guarded switch here. As you can see, normal cutout stabilizer. So this is for the horizontal tilt. I will show you now the flight controls also. So I will show you also the flight controls, what they contain. So in the flight controls section, I will show you the flight controls. Now I will show you the overhead panel, also the electric system, the left and right engine IDZ. So I will start with the flight controls now. So you have control the flight controls of the aircraft, then we're gonna make an engine start demonstration. So as you can see here, we have this side stick here for controlling the flight controls of the aircraft, so I can control the horizontal tail for climb and descent of the aircraft using the control column on the yoke of the Boeing 787 or the 777. Also we can use the ailerons and the spoilers in the left and right wing using the control wheel, also the rudder pedals for turning left and right, as you can see, for making turns to the left and the right. So the horizontal tail, the ailerons and the spoilers, left and right wing, the control wheel, horizontal tail, the elevator, and the rudder pedals for the vertical tail, the stabilizer of the aircraft. Also the nose wheel steering, and the rudder pedals we have the tiller for the nose wheel steering, the ground at some speed, the toe brakes, and also so you will see here the flight controls. We have the side stick, we have also the horizontal trim stabilizer, so you can climb and you can descend the aircraft like this as we fly. You can see. So this is the climb, descent of the Boeing 787. Also make turns to the left and to the right. You can see how responsive and quick the side stick is, or the yoke. We have also the thrust levers here. Command, you move the thrust levers forward or backward, so you adjust the thrust levers position. You can also use the trim here, the horizontal tail trim stabilizer, pitching up and pitching down the aircraft. So you can see the horizontal trim stabilizer here. So we climb, descend. You can see the side stick position is proportional to the yoke. Also the rudder pedals for making turns left and right, and the nose wheel steering. We use also the tiller there for the nose wheel steering. So you have full flight controls in flight, like this. Like you can see also the captain and the left and the right side are interconnected, so they move the same way together in flight. So I will show you now a little bit the outside view also, using the flight controls and the side stick of the Boeing 787. So you can see here again we have this. We can also extend so we can climb the descent again, make turns left and right. So this is the descent, the climb turns left and turns right, as you can see. So you see the side stick position proportional here. So all these are the flight controls for now for the Boeing 787. So I go now inside and show you all the rest of the system. Also with the overhead panel, we're gonna make an engine start demonstration. After the engine start demonstration, show you the systems, the displays of the. So after the engine start demonstration, we're gonna make a complete flight from takeoff, climb, cruise, descent, approach and landing in the end part of the video. So stay until the end part of the video. I'm Thomas Hatsios, the British American pilot flying the Boeing 787-900 tonight's flight. So I will start now with the displays. So and the overhead panel, you can see in the overhead panel we have the left and the right IGT integrated drive generator that will produce alternate current 120 to 200 volts, 400 Hz frequency. Also the batteries with 48 ampere hours direct current. The APU, we have the auxiliary power unit, the smaller turbine. We need to start the engine in the ground. Also you have gonna make an engine start. We need also from the APU electric power and pressurizer, a lot of pressurizer for the engine starter. You're gonna see also we have the hydraulic, the left and the right engine. We have the fuel tanks, the left and the right wing fuel tank, the center tank, the fuel booster pumps, the forward and the up, the cross switch valves, and also the fuel jettison, the rammer turbine, the primary flight controls, the inertial reference system with the ADU, the inertial reference unit, the cabin pressurization, and the bleeder from the left and the right engine. So also now the overhead panel, and then you will see here the displays. So the overhead panel here contains all the systems. You see also here on this view you can see better. So this is the electric system, the hydraulic system, the fuel system, the left and the right wing fuel tank, the center tank, the crossfeed valves. So you will see all the systems function like this. We have the primary flight control computers here, and the air data, inertial reference unit, the flight control surfaces, some other systems, window heat, passenger oxygen, rammer turbine. So we have the left and the right engine also. The left and the right wing fuel tank, electronic engine control, and the auto start, the pressurizer, the pressurization system with the bleeder from the left and right engine, and also from the APU. So also you know how to use these systems. Maybe from the overhead panel you can see the display, the electric here. So you can see the left and the right electric system, the APU, the battery. We need to start the APU, the external power, the APU generator, also here data, primary flight control computers, hydraulic, left and right hydraulic pumps. As you can see, we can use them either off or auto, like this. So this is movable, all these switches here. As you can see, also the auto start here. We need to start the engines later. To jettison, we can use the cross bleed, like this. The wing and engine got the eyes here. Also, we have the lighting system of the aircraft and the windshield wipers here. The cabin pressurization system. The bleeder from the left and right engine. Also, we can use manual, use the outflow valves for climb and descent. Use automatic, and we need the bleeder, the pressurizer from the APU here to start the engines. So I will show you now a little bit the systems here, the displays, the display. Also, we're gonna use some light for making the engine start demonstration. So you can see here. So we have the systems, the airspeed, the pitch ladder in degrees, the flight director, the flight mode annunciator. You can see the degrees, the airspeed guidance. Here we're gonna select a higher airspeed for the aircraft to fly. After takeoff, the heading of the runway. I'm gonna use 136 degrees. Also the altitude we're gonna be flying. So we have here also the displays. You can see we have some systems also display. You can switch to the systems instead of having this. So you will see here now we have the hydraulic system, the APU is running, the oxygen and the liquid cooling, the electric, the left and the right engine IDG, the APU is running, the battery voltage here and the APU battery, how many volts you have, which system functioning, the left and the right engine, hydraulic system 3000 psi each system, where the hydraulic fluid goes, the electric and the shut-off valves, and the hydraulic fluid quantity. The fuel, we have the left and the right wing fuel tank, the center tank, how much fuel we have in the left and right wing. Also forward and aft fuel booster pumps, the low and high pressure fuel valves feed the left and right engine. The cross feed is off. You can feed either engine with either tank or either pump. The APU is fed from the left wing using the DC motor. Total fuel on board 34,400. Minimum fuel temperature below which the fuel is freezing minus 37 degrees. So you have also the total fuel here. You can see the gross weight also and the temperature of the fuel. So we have also the bleeder, the pressurizer from the left and the right engine. The doors are closed, the cabin can be pressurized. The landing gear, you can see the temperature of the brakes and the pressure of the tires. The flight controls here. You move all the controls here, you see here everything is working. Also the stabilizer trim and the rudder trim, the FE's display, the maintenance circuit systems and circuit breakers again systems, and we have two last pages, the info and the checklist here, normal menu, just like in the Boeing 787 receive, and the communications. So this completes this. We have the CDU, and also We have CPU here. So we have navigation display, and so we have all the systems ready. We can start the engines. Now like this, we'll turn off both fuel control to the left and right engine like this. Fuel control off. You will see the fuel flow is off here, and the engines are shutting down actually. So this will shut down both engines, and then we go for the takeoff. You can see the right and the left wing. Both engines off. We need to use the auto start now. Over here, both auto start, the left and the right. We're gonna have some lights reconfiguration in the overhead, some systems. And you see here message. We have the N2 increasing, and we need to start above 20% the fuel control, like this valves. So this will engage the auto start and the fuel flow. So you see the auto start is running right now. For the left and the right engine, we have the auto start message. So we are above, we almost start both engines. You can see them spinning. Auto start above 58%, 100%, and the engines are running. We have the message now that both engines are running. So we can also fix the flaps here. And we can advance now the thrust levers and go. We are ready for takeoff. So we need only to taxi into the runway for the takeoff. So advance parking brakes off. We take the clearance from the air traffic control for takeoff. And we use this lever here for nose wheel steering, as you can see. So we align with the runway orientation and heading, flight director off for takeoff, and advance the thrust levers like this for the takeoff. So we advance the thrust levers forward and go. So we have takeoff power set, 90 knots, 100 knots, V1, 120, 140, we rotate, as you can see, and keep going. So we have the positive rate of climb, landing gear up, and here we go, positive climb. So we keep climbing. We are above the ground level. The airspeed is increasing. So you can see we are 165 knots, the stall speed, the flaps position, the altitude 5,000 feet above the ground level. So we keep climbing, and we're gonna be having like 20 more minutes about for this flight. So this is the Boeing 787. We keep climbing. You can see also we have here the flight plan we have to follow, the rate of climb of the aircraft. You can see the trend line is increasing. We have more of the flight plan, and we can start making the turn now. So we keep making a turn here. So this is the Boeing 787-900 cockpit. We need to cross through a couple of things. A waypoint here. The first waypoint is the intercept. We are 4 nautical miles away from that. As you can see, the airspeed keeps increasing, and we need maybe to retract some flaps to increase the airspeed. As we climb, you can see we have to cross through this waypoint now. As we fly with the flight controls also manually. So we fly with an airspeed of Mach 0.4 right now. We can see the whole of the Switzerland here, the lakes, the other lake we're gonna cross here, the Germany, my homeland, the Germany and the Bayern Munich. You can see the France on this side, and also the star sign with the Boeing 787. So we fly with 400 Mach 0.4 or about 500 kilometers an hour, or about 200 meters per second right now. So we need to keep climbing, as you can see. So we need to cross also the other waypoint here. So we have 18 more minutes. Increase the thrust as we climb. We need to make a turn now. So you can see the stall speed here, the airspeed, and the altitude we're flying through. 21,700. Need to increase. So we have the following here of the waypoints. You can see the thrust commanded right now here, and the autopilot settings. I'm flying with maximum thrust right now. So we cross 33,000. $34, $35. So we are 35,000 feet here, as you can see, and keep climbing. 35,400 feet, and we cruise with my own flight control. We have also the lake here, the Germany, the Bayern Munich, my homeland. So the France and the galactic view, and we keep climbing. So 36,000, keep climbing. We're gonna use higher altitude for that. So we are 37,800 feet. You can see the handrails now coming off from the engines, the frozen vapors, and we have 15 more minutes to go back home. So we cruise now 28,000 feet. We have the lake and the Bayern Munich, so we need to start making the turn now over here. So we have also the cruise level here. We have almost reached. And we're making the turn, as you can see. So the cruise level here, and we need to take the turn back home. As you can see, we're cruising at 29,000 feet above the Switzerland, and we have the frozen rivers, so also need much steeper turn, and also need to increase the airspeed now. We use light level fence, and we cruise now here. Back to the home, as you can see. We have like 13 more minutes to cruise manually, as you can see here. So we need also to retract the flaps to increase the airspeed. So we need to increase the airspeed like this. You can see we are cruising now manually here. We don't need to increase the airspeed. The auto, the head-up display, what it displays. So now I'm cruising manually about 600 kilometers an hour, 250 meters per second, overflying here the Switzerland. So we have the frozen galaxies here, and the view, as you can see, over Switzerland and the lake, the Bayern Munich, the Germany behind us, and the France. So hope you like the view of the galaxies here and the star sign. Flying manually. Now we're gonna use the autopilot in a couple of seconds. That's full display. So this is how you fly manually. We're gonna be flying with 900 kilometers an hour, or about 900 kilometers an hour in a couple of seconds. So keep flying manually. We can connect also the autopilot as for display here. See how it works, the autopilot, the LNAV, and we're gonna have the altitude also change for the descent. So we need now to fly with the autopilot, as you can see, and we have a few more minutes left, like 10 more minutes for this flight, and we are cruising back home. We have the autopilot connected now. Here you can see the display, The autopilot is on. As we are descending for the approach and landing, we're gonna be flying with higher airspeed now, about Mach 0.781. So we keep descending over here. We have idle thrust set now, and we're going for the landing part. We need about 10 minutes for the landing part here. So we're gonna be having some overspeed now, use some speed brakes, and decrease the airspeed here now. Keep descending. We're flying now with about 900 kilometers an hour, or about 300 meters per second, as you can see. Autopilot connected here and here. Keep descending. 7 minutes left for this flight. It's landing gear down. So we can disengage the autopilot like this. Take manual control of the aircraft. Keep descending a little bit more. And we have 6 more minutes left for this flight as we keep descending. 15,000, 14,000, 'So this is the manual control of the aircraft. We need to approach now. I used to use lower airspeed for the approach. And now we're gonna start using some flaps to slow down the aircraft. And now the ILS localizer here, the Ilsloc. So we need only to make the turn now for the airport for the approach and landing. And we have 5 more minutes left. So we are here. Use a bit more airspeed. as we are descending, and we have the Atlas localizer now. We're gonna be aligned with that. Need 4 more minutes to approach and land in the runway. So we're gonna have a nicer view like this, I believe, of the aircraft as we're gonna touch down the runway. So we can see we are approaching for the landing. We have the airless localizer, the needle, the glide slope, the radio altitude. We are 2,400 feet above the ground. The airspeed, the stall speed, the flaps setting. So this is how we approach using the flight director for the airport. Also use a little bit more flaps here for the approach. So we are here. So touchdown, parking brakes, and reverse, full reverse. So we have full reverse. So this is just landed to the runway. You can see. So you can see we are fully stopped now. So that was the flight complete. You can see all the data are correct. You can see also the nozzle here is pretty much safe here. We have no breakouts of the landing gear, all the metal parts. Also, I'm gonna show you a walk around the landing gear behind it. As you can see, the left and the right landing gear here, all the wheels and the metal parts. The aircraft is very safe, starting where it should be. There is no breakage in any tire or any metal part. The aircraft, the left and right, and the nozzle. So the aircraft is starting up the way it should be, the runway. So we can use it again for another flight like this. So that was Thomas Hatsios, the German-American pilot flying the Boeing 787-900.